Okay, just in case you want to look at it again at home. All right, so here we go. Question number 1, find the quotient and then write it in standard form. I tried to keep the same directions. Now, you don't have to write anything because yours is multiple choice, but just so you know, standard form would be A plus BI. And I know that because I see some I's. So I know I'm going to have some imaginary things happening. Okay, here's the key to this problem. You can't have I's in the denominator. So how are you going to get that out? What are you going to do? Something conjugate. What are you going to do with that complex conjugate? Multiply top and bottom by the complex conjugate. Okay, so what we're going to do is we're going to multiply this guy by a top and a bottom. All right, so what we're worried about is the denominator. So if my denominator is 2 minus 5i, we're going to multiply by 2 plus 5i. Good, top and bottom. Okay, good call. What if my denominator was 2 plus 5i? What would I multiply by? 2 minus 5i. All you're doing is changing the sign on the imaginary term. That's it. Okay, good. Now, I always like to put parentheses around them because it reminds me I have to FOIL. Everyone's getting FOILed. So here we go. 6 times 2 is 12. 6 times 5i is 30i. 2i times 2 plus 4i. And 2i times 5i is plus 10i squared. Okay, we'll clean that up in a minute. Now our denominator, we're going to have 4 plus 10i minus 10i minus 25i squared. Okay, everybody all right with that so far? Okay, we just FOILed him out. All right. Yeah, so let's just start combining here. So I'm going to have a 12 in the top. 30i plus 4i is 34i. All right, here's the tricky part. What is 10i squared? Minus 10. Remember, I squared is -1. So whenever I see I squared, I just cross it out and I change the sign. So I'm really going to have minus 10. Now I'm going to end up combining the 12 and the minus 10 in my next step. All right, down here in the denominator, I have a 4. My 10s cancel. And then what is minus 25i squared? Plus 25. I squareds go away and we change the sign, right? And that's what we should end up with. Everyone okay with that so far? Okay, I'm going to combine 12 minus 10. So that's 2 plus 34i in the top. And I have a 29 in the bottom. Okay, now the standard form means 2 pieces. So this would not be an answer choice. Your answer choice is going to be split up like this. Just like that. You'll have both pieces. I don't think yours can reduce. I think it's just like this. And then that would be the one that you would choose. Okay, so the key to this problem is 2 keys. First key, complex conjugate, multiply top and bottom by it. Make sure you know that. Second key is going to be I squared is equal to -1. So make sure you remember that little piece. Sound good? Any questions on that guy? Okay. All right, well, let's look at number 2 then. Okay, number 2 wants us to solve the equation, and then there's a second part. Check all solutions. Now, the reason they're saying check all solutions is not just because you should always check your work, but remember, when you square something like this, when you square square root, a lot of times, hint, 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 you will come up with an extra solution that's not true. That's going to happen here. You're only going to have one answer that works. The other one is extraneous. It's not going to work. So you're going to have to check your answers, okay? Because what's going to happen on the multiple choice is one of your answers is going to have both. One choice will have both answers. Then one choice will just have one answer and another choice will have another answer. And then there'll be something weird happening with Z, right? So you want to make sure that you're checking. So I want to get the root off. So how do I get a square root off? We square it. So we're going to square both sides. Now this right side's a little strange, the way that he's not like x minus 6, he's 6 minus x. Leave him alone, but I'm just warning you, it's going to make foiling a little bit weird in your mind. Yours is going to be just like that. So your left side is 2x plus 12. Your right side, what does that mean if he's got a 2 on him? There's 2 of those packets, right? 2 of those packets. Make sure you do that. Okay. And now we're going to FOIL that out. So I'm going to have 2x plus 12 equals 36 minus 6x minus x plus x squared. Okay, the goal is we're going to get every term on one side. Now, since my x squared term's already positive, I'm going to move everybody to the right. So I'm going to combine some terms and move everybody to the right. Okay, I'm just going to take my time. Minus 6x is going to be minus 12x plus x squared. All right, let's get everybody in the right order too. I don't like that x squared being at the end there. But let's see, first I'll go ahead, let's subtract 2x from his little partner. I'm going to do this in one big step. You don't have to. I'm going to subtract 12 from his guy. Okay, we don't have to do number 3, so I'm just going to use his space. All right, I'm going to end up with a 0 on the left, and I'm going to have 24 minus 14x plus x squared. But I want to put him in descending order because my brain doesn't like that. So there we go. Okay, everybody okay with that? We FOILed it out. We moved all our terms. We put it in the right order. Now we have a quadratic. Okay, you can put him in the quadratic formula if you're just a formula kind of kid. I'm going to factor. He's a monic. Bless you. Okay, I need factors of positive 24. That means they're either going to both be positive or both be negative, and they need to add to be negative 14. 12 and 2, and if they're both minus, that'll work. Negative 12, negative 2. How about that? Okay, we're going to keep going. This is going to give me x equals 12 and x equals 2. Both seem like nice little choices. If you stop there, you're going to see that choice and you're going to think, oh, look, I'm so good at math, and you're going to circle it, right? But we're not going to do that because we're going to check because it told us way up here to check. So here we go. Let's check. All right. This is the only one where this happens, by the way. Okay, this is just the root one. Okay, I'm going to go back up to my original problem, and I'm going to have square root of 2 times 12 plus 12 equals 6 minus 12. Okay, this is going to be 24 plus 12 equals negative 6. I can already tell this isn't going to be the one because a root can't equal a negative number. Sure enough, the square root of 36 is 6. It's not negative 6. So this is not going to be an answer. So if you want it, if you're pressed for time, go ahead, Joy. Oh, because it's right. Normally it would, but that's what's in the problem. So that's what I put in is 6 minus 12 because that was the original. Up there, whatever that tells you to do, put it right in up there. Okay, let's just go ahead and check the other one just so you can see what it would look like if it worked. Okay, so I'm going to have 2 times 2 plus 12 equals 6 minus 2 on the right. This is going to be 4 plus 12 equals 4. Root of 16 equals 4. Sure enough, that's right. So you would pick the 2. Everybody got it? Okay, so check it back in the original and only one will work. Okie doke. Okay, everybody good on those 2? We don't have to worry about 3. Okay, let's look at number 4. All right. So number 4, we're going to cheat the system, okay? Because nobody has time for number 4. All right. Number 4 wants you to take this poly. He's a 4th degree, so he's going to have 4 answers. And it wants you to find all the zeros. Okay, technically, this is going to be how you're supposed to do it. Remember, this was test 3. You are supposed to create a list of possible rational zeros, right? Factors of the constant over factors of the leading term, leading coefficient. Then once you get those possible rational zeros, you're supposed to do synthetic division till you get one without a zero. That'll knock it down to a 3rd degree. Do it again till you find another one with a no remainder. That'll knock it down to a 2nd degree. And then plug the 2nd degree into the quadratic formula to find the last 2 because they're not rational. Okay, we don't have time for that. You'll be here the rest of your life. So we're going to just do what I know you guys would probably do anyway. Grab the answer choices. Let's plug them in and see which ones are right. Okay, so here's what I want you to do. I don't want you to worry about these 2 crazies in the back. Don't worry about them. Okay, don't look at them. Don't even worry about them. Here's what I want you to notice. Your choices then, using just these nice little 1s and 2s, are every one of them is completely different. So what you're going to do is use the process of elimination. You're going to plug in each whole number until you find 2 of them that equal 0. Okay, we're going to use the process of elimination. We are going to plug in each one of these, a -1, a +2, a +1. You know, there's not that many. There's only 4 choices, really. The negative and positive version of 1 and the negative and positive version of 2. And we're going to find out which ones equal 0 when we plug them in. Those are going to be our answers. Okay, so let's start. Okay, I'm going to start with -1 just because he's my first choice here. So what I'm going to do is take this original poly and I'm going to plug in -1 for all my x's. I'm going to have a -1 to the 4th minus 3 times a -1 to the 3rd minus 20 times a -1 squared minus 24 times a -1 minus 8. Now, why am I doing that? What is that telling me? Remember, we're finding the zeros, the answers to this poly. And one of the characteristics of a 0 or an answer is that when you plug it in and evaluate it, you come up with 0. So we're going to know if it's the right answer if we come up with a 0. So we're just using that little fact to do that. Okay, let's see what happens here. So -1 to the 4th is 1. This is going to be a +3. This is going to be a -20, a +24, and a -8. When I do all that in my calculator, sure enough, -1 gives me 0. Does everybody kind of see how I did that? I just plugged it in. I'm looking to see which 2 of these are going to equal 0. -1 equals 0. Okay, which means that -1 has to be one of my answers, which means it can't be B and it can't be D. So I've already narrowed it down. Does that make sense? We're just kind of going at this backwards because we don't have time to do it any other way. Okay, now I need to try 2 and -2 and see which one of these works. So if I try 2, okay, I'm just plugging in 2. I'm going to evaluate it. Everywhere I see an X, I'm throwing in a 2. Okay. I'll go ahead and tell you when I do all that in my calculator, I get 144. So is A the right answer? No. It's got to be C. And then you can check that by looking into -2, right? Now I can try -2 in here if you just want to make sure. And when I do that, sure enough, I get 0. And then I know that -1 and -2 are the answers and C is my answer. Does that make sense? So don't worry about these real complicated ones back here. Don't just forget about them. You're going to have, little whole numbers in the front. And all you're going to do is start plugging them in to your equation. And whichever two give you 0, that's going to be your answer. Only one of them will do that. Okay, I mean, I hate to teach you to trick, to trick them, but this problem really has no business being on a final exam. It's too long. So we're just going to have to do it that way. Is that okay? All right. Okay. Let's look at 5. Okay, number 5. So we have this big long equation. We want to complete the square and write the equation in standard form. Then we want to find the center and the radius of the circle. Okay, think we got it? Okay, we got to remember how to complete the square. What we're trying to get to is we're trying to turn it into this form. Remember that guy for the circle? That's what we're trying to do, but we're going to have to complete the square twice in order to do that. Okay, so what we're going to do is put our x terms together, our y terms together, and then move that constant to the other side. And then we're going to leave blanks, right? Because we have to complete the square. So I'm going to have x squared, and I'm going to put his little x term next to him. So minus 8x, and I'm going to leave a little blank. I'm going to add a blank. Then I'm going to put plus y squared, and I'm going to put his little y term next to him, and I'm going to leave a blank. Equals. Then how do I get 32 over to the right? Subtract him, so he needs to be negative. And then I have 2 blanks on the left, so I better have 2 blanks on the right. Okay, so all I did was reorganize. I put the x terms together and I added a blank, y terms together, added a blank, moved the constant, and then I evened up the blanks. Okay, what in the heck is going in the blank? Okay, remember what goes in the blank is this. That's going to be the key to this problem. B divided by 2 squared. That's what's going in each blank. Okay, so for the x blank, who's my b? -8. Okay, so -8 divided by 2 is going to be -4. -4 squared is 16. That's what's going to go in each first blank. Don't forget to put him over on the right. Everybody see what we did? Okay, no? Okay, are you good? Are you okay with how we rearranged it? No, okay. So I put the little x terms together and I added a blank. And then I put the y terms together and I added a blank. And then he doesn't have an x or a y, so I moved him to the other side. And then I had 2 blanks here, so I added 2 over there. Okay, so I just kind of rearranged. And then what goes in the blank is going to be b over 2 squared. So this is the b for x. So I did -8 over 2, that's -4. Squared is positive 16. So he goes in both first blanks. All right, now I need who goes in the second blank. So who's the b for y? -10. Divided by 2 is -5. Square -5. I get 25. He's going in the other 2 blanks. Okay. Sound good so far? All right. Now we're going to turn this big mess into this equation. So we're going to look at these 3 terms here, and we're going to make a parenthesis packet with them. So remember, it's the square root of the first the sine of the middle, the square root of the last. So it's going to be square root, sine, square root. That's his packet. Okay. And then we have a plus. And then I'm going to make a packet for y squared. Square root, sine, square root. Okay. And then I'm going to just clean up the right side. I'm going to put that right into my calculator. And it turns out to be 9. Okay, that is standard form. So we wrote standard form. Now, remember, this is what it really stands for up here. We want to find the center. Now be careful, your center's H and K, and they're already negative here. So our center's not going to be -4, -5. Our center's going to be 4, 5. It's the opposite of what you see in the parentheses. They will have a choice for you that's -4, -5. Make sure you pick the opposite. Okay, and then what's my radius going to be? 3, because remember, this is r squared. You have to take the square root. They're going to have 9 as a choice for your radius, but you want to take the square root. Okay, and then those are your answers. Is that okay? That's a toughie. You got to remember what to do on all that. Okay, so opposite signs for the center, square root for the radius. Okey-doke. All right. Brings us to 6, 7, and 8 on the next page. Everybody good with this one then? Okay. Okay. All right. So this little guy here, we want to find the x-intercepts and tell whether they cross the x-axis or touch and turn at the x-axis. So it doesn't tell us to find the multiplicities, but we have to find the multiplicities to know what it does, right? Okay, you're not going to have anything weird out in front. So you guys that can't figure out, when there's a GCF, you're good. And you're not going to have any of those weird imaginary parentheses that you have to ignore. It'll be just like this. It's very straightforward. Okay, you're going to have 3 x-intercepts because I see 3 packets. Okay, what is this x going to equal? -9. This x is going to equal 4. And this dude over here is going to be 9. Okay, so we have 3 x-intercepts. I just set each packet equal to 0 and solve. That's it. Okay, now it doesn't tell us to find the multiplicities, but we need to know what they are in order to do the next part. So the multiplicity is just the exponent on the packet. So I don't see an exponent on his packet. So what's his exponent? 1. Same thing for this next one. I don't see an exponent on his packet, so it's going to be 1. All right, what about the 9 though? What's his multiplicity? 4. Okay, now it wants us to say, does it cross the x-axis, cross through, or does it touch and turn? Okay, do we remember if it crosses through, what kind of multiplicity does it have to have? Odd. Odd multiplicities cross through. What about touch and turns? Even. So even though it's not going to tell you to find your multiplicities, you have to pay attention. So what's going to happen at -9? It's a cross or a cross through, right? Because 1 is an odd number. We're looking at multiplicities. Okay, what about at 4? Cross. 1's an odd number. What's going to happen at 9? Touch and turn. Touch and turn, because its multiplicity is even. It's a 4. Okay, so odd multiplicities cross through, even multiplicities touch and turn. Your multiplicities are just the exponents. That's it. Okay, is that okay? Okay. I do too. All right, number 7, use synthetic division to divide. Okay, your problem is going to be just like this. It's already in descending order. There are no missing terms. And you're going to have a really ugly remainder, just like this problem. So it's a great problem for you to practice. Okay, here we go. For synthetic division, who is going in the shelf? A 4. How do we know that? Yeah, you can either use the opposite sign or more specifically, set it equal to 0. X equals 4, so 4 goes in the shelf. Okay, now we just want our coefficients in order. So we have a 1, a -3, a -7, a -14, and a -5. They sound super ugly, right? We leave a blank. We're going to add and we bring down the first one. Okay, everybody good on that? All right, here we go. We're going to do 4 times 1. Where does the 4 go? Right up here under the -3, right? We add, we get another 1. 4 times this one pops up here. -7 plus 4, -3. 4 times -3 is -12. We're getting a little ugly. Okay, we add these, we get a -26. 4 times -26, yuck, -104. We add it and we have a -109. So we have a remainder, just like you will. Okay. All right, everybody okay with getting the numbers? Now we have to figure out how to write a poly with these guys. So my original poly was a 4th degree. What's my answer going to be? A 3rd degree. Go down 1. Okay. So, and these are the coefficients. So I'm going to have 1x to the 3rd. I'm just going to write x to the 3rd. Plus 1x to the 2nd. I'm just going to write x to the 2nd. Minus 3x minus 26. And then remember, this last guy is your remainder. Remember how to write him? Good. You go ahead and write him out. And then he goes over this denominator from the beginning. And there you go. Okay. So we just use this denominator as his denominator. That's it. All right. Sound pretty good? Questions on synthetic? All right. Let's see if we remember what to do about a vertical asymptote. Okay, a vertical asymptote, you solve your denominator. That's it. You set it equal to 0 and solve. That's how you find vertical asymptotes. So I don't care what the tops are for either one. I just put 2 on here to practice. I figured that would work. Okay, on this little guy, we actually have to factor him because he's an x squared. What's x squared minus 9? Difference of squares. Okay. We're going to set each one equal to 0 and solve. I get x equals 3, x equals -3. Those are his vertical asymptotes. That's it. Let's look at this little dude. Okay, he doesn't have to be factored because he's not a square, but I do need to set him equal to 0 and solve because he's kind of yucky. Yeah. And he's x equals 1/5. So the top means nothing. Just cross it out and solve your denominator. Okay, set him equal to 0 and solve. All right, so that's vertical asymptote. That's a vertical. Wow. Okay, now let's look at horizontal asymptote. Remember, horizontal asymptote, you have to compare the degrees of the top and the bottom. All right, now I don't want to fill your little brains with stuff you don't need. Okay, we've already had a test over this where you had to learn all 3. So let's just worry about the one that's going to be on the final, which is this. Okay, so for horizontal, you're comparing your degrees. You're going to have a problem just like this that has the same degree, top and bottom. See that? They're both squares. So your answer is going to be y equals the leading coefficient in the top divided by the leading coefficient in the bottom. because it's the same degree. And then if you can, reduce it. If you can't, you leave it alone. So for this particular problem, degrees are the same. What's my horizontal asymptote going to be? 8/3, 8/3. Because if the degrees are the same, you just take the leading coefficients, 8/3. Now, what if the denominator, if his leading coefficient was 4? What if it was 8/4? What would we reduce it to? 2. Yeah, so just be prepared if you can, but you know, it's multiple choice, so you'll see one that works. All right. Is that okay with everybody? All right, so those are your asymptotes. All right, so far we have really done a lot from test 3. It's a great test 3 review. Okay, so, all right, number 10, we're still in test 3. Okay, so this, all it tells you is solve the inequality. You do not have to graph the solution set. Let's cross that out because you're not going to have anything like that on the final. It just wants the answer. Okay. All right, so if you have an inequality like this, and you have a quadratic on the side, this is the one where you have to find the boundary points and test the intervals. Remember that? We're gonna solve this, but what we find, those aren't the answers, those are the boundary points, and then we make little intervals and we find test points in them, and you guys always find test points that aren't in the actual interval, and it's a whole thing, right? Super fun. So that's what this guy is. All right, so let's practice him. This is from test 3. All right, first of all, we need to solve. Well, we can factor him. He's a monic. So I need factors of -24. That means one person's negative, one person's positive. They need to add to give you 10. Well, 12 and 2, 12 and 2. And who's going to be positive? The 12. All right, let's talk about that for a minute. 6 and 4 multiply to give you 24. Absolutely, right? And you could make one positive and one negative, but there's no way a positive and a negative 6 and 4 will add to give you the 10. It would only happen if this was a positive 24. See that? So you got to be careful with that. Look at that good example, Ms. Holcomb. So make sure with your factoring that it meets both criteria. They add to give you that middle number, but then they multiply to give you the other. Okay, watch your signs. All right, so I see x equals -12 and x equals +2. These are the boundary points. That's what these are. These are not your answers. So you have to now draw a number line, and you need to put these on the number line. So there's -12 and there's 2. And I'm just going to make some little intervals. And I made 3 little intervals from these boundary points. Okay. All right. Now what I'm going to do is name each interval. Okay. So I notice I have a greater than sign. Is that parenthesis or hard bracket? Parenthesis. So this particular interval is going to be -∞ to -12, both with parentheses. Okay, yes, good. This interval is going to be -12 to 2, both with parentheses. Because of this, yours are going to have parentheses also. We're practicing it just like you're going to get. And this guy's going to be parenthesis 2 to infinity, just like this. Okay, now is kind of the time when if you want to make a little chart, you know I love a good chart. We can make a little chart, or you can just come up with a test point and try it. So it's kind of up to you. Maybe I'll just try not to be too extra and I'll just give you a test point. So, all right, we have to come up with a test point. You have to name any number in the whole wide world that's between this interval. We're not going to say 5. Is 5 in this interval? No, it has to be in this interval. So what would be a good number between -∞ and -12? You can't use -12. -13 sounds good to me. I mean, there's no right or wrong unless it's not in the interval, right? Okay, what about a nice test point between -12 and +2? Yeah, you know I love a 0. Okay, what about a number between 2 and infinity? How about 3? Yeah, good. Those are the numbers I already did, so that worked out perfect. Okay, now you're going to test the test points. You're going to plug them in to this original poly back at the beginning and see if they hold true. That's what you're going to plug them back in. So let's plug -13 in for x. When I say hold true, I mean whatever happens on the left has to be greater than 0. That has to stay a true statement. All right, well, if I work through this, I came up with 15. I don't know if that's necessarily true or not, but anyway, I know he's greater than 0. Everybody see that? And 15 is greater than 0, which means this interval is correct. Everybody agree with that? Okay, let's try 0. Okay, I'm going to do 0 squared plus 10 times 0 minus 24. I got a -24. Is that greater than 0? No. So that interval is not true. Okay, now I'm going to take 3. All right, see if it's greater than 0. This is why I'm not sure if it's right, but I came up with 15 again. Could that really be true that both of these I picked came up to be 15? That seems super sketchy. Anyway, it's positive. So because it's greater than 0, that's going to be true also. Does everyone see how we tested that? We just picked a number in each interval. We plug it into the original and we see if it's true, if it really is. Now, what if this were less than 0? If this were less than 0, which one of these intervals would be correct? The middle one. Yeah, this guy. So we have to do whatever this says. Okay, so since these two are correct, we're going to write those intervals. We're going to have -infinity to -12 and 2 to infinity. And what do we put between them since we have 2? The union. Okay, there you go. So that problem's a lot of work. It's deceiving. So, but keep in mind how to do it. All right. Yeah.
I felt so smart.
You did great. So that's pretty much chapter or test 3. That's your test 3 material. Okay, now we're going to go into test 4, which you guys are super duper good at because you just aced the test. Okay. Oh, by the way, I feel very sorry for next door because apparently you guys went out and told them how easy the test was and it was multiple choice. So I had one little girl that was over there say, Miss Holcomb, I heard the test was super easy. It's multiple choice. And I was like, okay, I wouldn't bank on that. So anywho, all right. You might want to be careful what you tell them. Theirs is not always the same as ours. Okay, here we go. So number 11, use the properties of logs to expand. Okay, we know what that means. That means however many letters we see, that's how many logs we have. So I see 1, 2, 3 letters. I'm going to have 3 logs. All right. And the base is going to be 4 every single time. That does not change. So be very careful on this multiple choice final, because some of it is going to have like log base 8 or something where your base changes and you want to leave your base alone. Okay, so here we go. I'm going to have log base 4 of x squared. Now you and I both know we're going to end up moving that exponent to the front, but I'm just going to do baby steps. All right, now he's multiplied by y to the 6. So what's going to go here? A plus. Log base 4 y to the 6. Good, base is the same. Now I have a z cubed in the bottom. What am I going to do for him? Subtract, because he's in the bottom. Log base 4z cubed. Okay. Now we're going to take those exponents and we're going to move them in the front as coefficients. This test is sneaky. This is going to be one of your answer choices. And technically it's kind of right. It's just not expanded as much as possible. So you want to keep going. So your final answer should be 2 log base 4x plus 6 log base 4y minus 3 log base 4z. And there you go. Okay, that should be fresh in your little minds. Does that sound good? Okay. All right, you do not have to do 12. All right, we're going to go on to number 13. You guys did pretty good on 13. There seemed to be one little disconnect I want to talk about. Okay, so to find the domain of the log, you guys remembered we don't care anything about the log. You guys were fantastic in taking your argument, and what did you do to it? Do you remember? Greater than 0. You did great. Always set it greater than, forgot how to spell, 0. You're always going to set your argument greater than 0. Okay, then you're going to solve. Okay, you guys would get all the way down to that point, and then you'd put it in a hard bracket. There's even a little, there's not even a line under there. He's just a greater than, right? So are we going to have parentheses or hard brackets? Parentheses. So if he's greater than -5, -5 to infinity. So this is going to be a choice, but you're also going to have this as a choice to try to trick you, just like you had yesterday. Don't do that. You know, this is greater than. This isn't a hard bracket. I mean, you even wrote it. So make sure you just follow that, okay? Everybody okay there? Okay, let's try 14. Okay, you do not have to do this. You do not have to give a decimal approximation. They didn't put that on there this year, so we'll just cross that out. All right, solve the equation expressing the solution set in terms of natural logarithms. That means your answer should have a natural log in it. What's natural log? ln. Okay, it's kind of like that problem we had yesterday where it said express your answer in terms of e, and then some of y'all picked something that didn't have an e in it. So if it tells you your answers in terms of something, that means that's in your answer. Okay, so you can automatically get rid of 2 choices that don't have a natural log in it. All right, so all you're going to do is take the ln of both sides. That's all. So ln of the left equals ln of the right. You're just going to take the natural log of both sides. Okay. Once you do that, it's a piece of cake, because what's the super secret base of ln? E. He has a super secret base of e here. And if this e and this e are the same, what happens? They cancel out. And you're left with x plus 5 equals the ln of 7. Now, be careful here. You're going to subtract 5 from each side, but your answer is not the ln of 2. It's kind of like that 7's in a radical. You can't mess with him. He's the ln of 7. Oops, I think I put plus 5 in my answer. I'm sorry. Minus 5. This is your answer, okay? So one of your answer choices is going to be ln of 2, but it's kind of like you can't break into this argument and start messing with it. It's the ln of 7, which is one term, minus a 5 on the end. Don't combine those in any way. Okay. All right, we got 2 word problems on the next page. Okay. Everybody okay? What in the world? Okay. Here we go. I'm going to switch. You good? Okay. All right. So 15, remember we talked about there would be one problem from section 4.5 that we didn't get to. This is your 4.5 problem. This is exactly the problem you're going to have with just different numbers. So we're going to make sure we can all do it. It's really similar to that. Remember how you would do the interest and you would have a formula and you just plug it in and put it in your calculator? That's all this is. Okay, only this is now your formula. Okay, This is a formula you may have seen if you have taken life science, if you've taken some biology classes. This is a real formula, all right? So what it is saying is X is your number of years, and it even tells you that. X is the number of years, okay? This is talking about radioactivity, like how much of a substance has decayed, all right? This little A sub 0 is one term. A sub 0 is the original amount. It's kind of like your P from your other situation. And then regular A is the current amount. Okay. And then X, it already tells you, is years. Okay. And then all you're going to do is you simply have two numbers that are given to you. One is going to be regular A and one is going to be A of 0. And all you have to do is read about which one's the original amount and which one's the current amount, and that's it. Okay, so here's our formula. It models the amount of a particular radioactive material stored in a concrete vault. X is the number of years since the material was put into the vault. If 600 pounds of the material are initially put into the vault, so what is 600 going to be? The first one, the A sub 0, that's going to be what originally went into the vault. How much time will pass for only 231 pounds to remain? That's the one that's on the left, the regular A. So it's the opposite of money. We're not accumulating. I don't want you to look at this and say, oh, the smaller one is the A of 0. The bigger one is the A of 0. And the smaller one is the A for the radioactive for this particular example, okay? That's how it's gonna be on the final. The bigger number is your A of 0 and the smaller is that. So we're gonna solve for X. So 231 equals 600 e to the negative 0.00866x. Okay, that's what we're solving for. So let's make sure we can put this in our calculator and we get it, okay? It's real similar to the bonus now that you had on your last test. Okay, so we're gonna divide by 600. All right, that's gonna give me 0.385 equals e to this crazy decimal, okay? I just divided both sides by 600. That's all I did. Okay. Now, because we have an E, what do you think we're going to do to each side? We're going to take the natural log of each side to get that E down. Okay. So I'm going to have the ln of 0.385 equals the ln of E to this crazy decimal. Okay. Now we know the super secret base of ln is E. So what I'm going to have on the left, I'm going to have ln of 0.385. What's going to happen to this here, this situation? They cancel, right? And you're going to get negative 0.00866x. And then all you have to do is divide each side by negative 0.00866. And just round it to a whole number. Okay, let's make sure you can do that in your calculator. So you're going to use the formula they give you. The bigger number goes on the right, the A of 0. The smaller number goes on the left. Then you're going to divide and get the E by itself. Okay. And then, hold on guys, because we got to fit in 30 of these bad boys. You're going to divide both sides by that and get this alone. Then you're going to take the ln. This ln is going to cancel, right? And you're going to have ln of 0.385 equals the exponent. And then you divide by this. So ln of 0.385, hit enter, divided by this. Okay, and you should be able to round to 110. Sound okay?
Wait, so you take the ln of 0.385
Uh-huh.
divided by that?
Yep. Here, let me do it in my calculator real quick and we'll call it a day. Okay, you ready? So I'm going to do ln 0.385, enter, divided by negative 0.00866. And then I just round it. Okay, so I was hoping to get to 18 today, but we're going to get to 16 instead, and there is no 17. So that's not bad, but we'll have to really book it on Thursday, but we won't have tests to talk about, you know. So I think we'll be fine. I'll let you go, and I'll see you Thursday. We'll finish it up, and I'll send you out this video.